Hey friends, welcome to my channel lecture series on power electronics. In this session, let us learn to design a buck converter. The image shows a basic buck converter which has a MOSFET, a diode, an inductor, a capacitor and a resistive load. We are going to design a buck converter where we have to determine the value of the inductor and the capacitor given the switching frequency, input voltage, output voltage and the ripple in the output current as well as output voltage. The problem statement is to design a buck converter to convert 36 volts DC to 12 volts DC while supplying a resistive load of 10 ohms and operating at a switching frequency of 25 kilohertz. The input voltage is given as 36 volts, the output voltage is given as 12 volts. It is connected to a resistive load of 10 ohms and it is operating at a switching frequency of 25 kilohertz. We are asked to determine the duty ratio of the converter, minimum inductance required for continuous conduction mode, inductance required to limit the inductor current ripple to 25%, output capacitance required to limit the output voltage ripple to 5%. So we have to select practical values for L and C for simulation, and we can simulate the designed converter using PSIM and verify the output voltage waveforms. The design specifications given in this problem are the input voltage, output voltage, resistance, the switching frequency of MOSFET, inductor current ripple and the output voltage ripple. Using all these data, we are going to design a buck converter. The very important step is to find out the duty ratio from which we will be able to find out the values of inductor and the capacitor using the formulae. Let us now calculate the duty ratio. The duty ratio is given by output voltage by the input voltage. Here the output voltage is 12 volts, input voltage is 36, and so the duty ratio is 0.3333, which is 33.33%. Using this, we will be calculating the value of inductor and the capacitor, because in the formula of inductor and capacitor the duty ratio is involved. While simulating the buck converter in PSIM, this duty ratio what we have calculated should be given as the switching point in the gating block of MOSFET. We have calculated the duty ratio as 0.333 and that should be multiplied by 360, which is 120. That is the point which is marked in PSIM here. As the duty ratio changes, that has to be multiplied by 360 and it should be entered here. We can also see here the frequency is marked as 25,000. So these points are to be noted when the simulation is done in PSIM. For calculating the inductor value, the formula used is L minimum is equal to 1 minus D into R divided by 2 into Fs, where D is the duty ratio, R is the resistance, Fs is the switching frequency. Already we have calculated the value of D and we know the value of R and Fs given in the problem. So substituting the values here, we get a value of 133.3 microhenry. For continuous conduction, we assume 25% higher value of inductance. So 25% higher than this 133.3 when worked out comes to 166.75 microhenry. Let us now get the value of the output capacitor C from the formula 1 minus D divided by 8L into del V0 by V0 into Fs square, where this del V0 by V0 refers to the ripple in the output voltage, which is given in the problem as 5%. The value of D we already have calculated. as duty ratio. L value also we have calculated, and the switching frequency is also given as 25 kilohertz. So on substituting all these values, we get a value of capacitance as 160 microfarad. The final design parameters are input voltage 36 volts, output voltage 12 volts, resistance 10 ohms, switching frequency 25 kilohertz. For this, we have found out the duty ratio as 33.33%, inductance as 166.75 microhenry, capacitance as 160 microfarad. Using all these values, we can apply in the circuit of a buck converter and try to simulate it using PSIM. Using the final parameters, the circuit is simulated using PSIM and the output voltage waveform is seen as in the next slide. Here we can clearly see that the input voltage is 36 volts marked by the blue line and the output voltage is 12 volts. So by knowing the input voltage and the output voltage, by calculating the duty ratio, L value, C value, we will be able to simulate a buck converter using PSIM. Thus, a buck converter was designed for 36 volts to 12 volts conversion. The duty ratio is calculated as 33.33%, inductor value as 166.75 microhenry, output capacitor as 160 microfarad, load resistance as 10 ohms. Converter operates in the continuous current mode. The design is verified using PSIM simulation.